Okay, so let's see what we've got. We've got delivery from an unnamed parcel company. And I'm just going to get it out with all the dexterity of a dyspraxic hippo. There we go. Okay, right. Wow. Oh, it's good packaging. Okay. Well, it's not damaged, so I can peel it off. So good stuff. Right. Oh, wow. Okay, so we've got our super starter kit. Okay, let's see what we've got inside there. So open it up. Wow, we have got loads of stuff. So we've got all sorts of wires, propeller. That I do recognize. That I can recognize as a USB cable. Batteries. Yeah, look, loads of stuff. I can see resistors. Okay, million and one things. Now, I think, well, let's just start at the beginning. I think we'll just start with the very first thing we've got, which if I can take it out delicately, you can tell that this is a physicist used to using slightly more robust equipment. We've got
or getting a technician to do it for you.
Oh, yes, okay, the technicians do it for us. We've got our original board, okay? So let's get started.
Okay, so let's have a little look at the board. So this bit here, this is where the USB goes in, and we can also put a battery in here as well. So normally we will keep the USB powered up on the board by the USB, and we won't need any batteries or anything like that. Okay, so we can clear this out of the way, but the battery can go in here. Now there's lots of bits and pieces of these components around. This itself is the Arduino, that's the chip itself. Now this board is designed for people like us that want to play around with it and want to try lots of different things. And it's really well designed. So over here is a little block of inputs and outputs, and these are all to do with power. So there's V in and ground and 5 volts and 3.3 volts. And we're going to use those to get power out of the board onto the system or out from the USB onto other bits and pieces of electronics. Down here, we've got 6 analog inputs. Okay, now you might ask what an analog input is, and we'll find out about that in just a moment. And over here, on the other side of the board, we have got lots and lots of digital inputs and outputs. So each one of these little inputs and outputs here, we can connect to LEDs and to motors and all sorts of different bits and pieces. Or we could connect switches and things like that to them. All right, now these other components here, so this is an integrated circuit in here, and we've got a switch over here, and we've got some LEDs over here. And later on today, we're going to get this LED up and working, and we're going to start making that one flash. And we've got some more integrated circuits down here and some transistors and other bits and pieces. But the thing is, what's really important for us at the moment, we don't want to tell you everything all in one go, otherwise the video will be 8 hours long and very boring. Okay, so Mr. Leroy, what is the difference between analog and digital?
Great question. Okay, the easiest way to think about it is to think about temperature. We'll go into the details of sound and everything a little bit later on, but let's think about temperature during the day. So when we get up in the morning, when I get up in the morning, you guys a bit later, it's usually quite cold. As the temperature goes on through the day, it tends to peaks around 3 o'clock, and then comes back down as the day goes on. Not perfect, but you get the drift. Now, that's analog. It's continuous. I can measure any point on this graph, and it's a continuous slope, it's a continuous gradient, it's a continuous graph. But what digital does is something slightly different. Digital has an on or an off, a 1 or a 0. If I was reading this with a digital, all I could do was say, okay, at 2 o'clock, where's the temperature? Oh, it's here. Well, in that case, it's above the green line, so let's call it 1. By contrast, if I measure it at 8 o'clock, all it can tell me is that it's below the green line, so let's call that 0. 1s and 0s, digital and binary. So fundamentally, all we're saying is, whereas with an analog, it gets all the information, digital can only tell us whether it's below a certain temperature or above a certain temperature at a time. It can't give us any more information than that. Okay, so we might as well get started. I've got the board out, a PCB, and I've got my, well, nice blue cable. I've got a USB connection on one end, so I know roughly where that's going to go. So we'll get it all undone. Eventually, there we go. Okay, so I'm going to have to connect one end into my laptop. Okay, so let's get that connected in there. And then the other end goes into this connector on the PCB. So let's plug that in. And okay, so I've managed to get flashing lights, which is a good start. What have I done?
No, that's good. So what happens now, see that little orange light that's flashing? That is actually output number 13.
Yes, I can see the 13 just there. Yep.
Yep. Well, that's how they check it's worked. So when the chip comes out of the factory, they program in for that one to flash on and off. So you can plug the board in and we know that that board is working.
Excellent. So we've got a great place to start. We've got a working board.
We've got a working board.
Brilliant.
Yeah. So what we can do now is we can go onto the computer and we can change the timing of that and we can play around and show that we're going to take control of that. So that's flashing every second. So we're going to switch to the computer now and we're going to program that ourselves.
Perfect.
Okay, so going over to the computer side of things now, it's not as scary as you think because the wonderful people have given us loads and loads of examples. So if we go to File and go to Examples, there are loads and loads of built-in examples for all the little modules. So we can have a look and see what other people have done and then we can play around with it, okay? So we're going to go to the basics and we're going to go to Blink. All right, and I'm going to drag this over here. Load of comments. I really like that. It's really useful to have. If you're writing, these are called sketches. If you're writing a sketch, write a load of comments on it as well. It's really good. But the sketch comes in 3 parts. One thing is bits and pieces you do at the very top. Another thing that you might do is the things that happen once. So when you first turn on the computer, if you remember me saying that these digital inputs and outputs have got to be, they could be an input or an output. Yeah. They can't be both. So they've got to be told at the very start, okay, I'm an output. This one's an input, this one's an output. So this is what's happening here with pin mode, that the LED that's built in is an output. And then over here, we've got our main loop. And that's the thing that's happening again and again and again. And so what we've got going on here is digital write, which means we're turning on our output, our LED, we're turning it high. Then we're going to delay for 1,000 milliseconds, which is 1. Okay, 1 second. And then we're going to turn our LED low, which will turn it off and delay that for a second. And then it was just going to keep looping and doing that again and again and again. So on here, you can see the LEDs turned on when it's high. Stays on for a second and then turns off and then stays off for a second and then loops and does that again and again. Does that make sense to you?
It does, because that's going to give a very different graphical representation to the one we looked at earlier.
Okay, so you want to show us?
Yep, I'll show you what that looks like in terms of graphs. Okay, so in the version we're just seeing on the board, the LED is coming on and off once a second. This is what the actual information looks like if we were to graph it. So if I look at this side, I've got 0 to 5 volts. That's how many volts are passing through. Don't panic if you're not sure what a volt is. We're going to deal a lot with voltage, current and resistance later on. Now, I want you to think about a time along this scale here. This is 1 second, okay? So if you remember, it came on for 1 second. So here is the light turning on almost instantaneously. It's on for 1 second and then it switches off. So at the top here it's on with 5 volts. The bottom here it's 0 with 0 volts. So it's off. Then we wait another second under here. Whoops. And then you can see that it's off for a second and then straight away it's back on again for a second. So with this LED, it's one of 2 spaces. It's either off down the bottom or on at the top, and it's a straight line going up.
Yeah, that's it, exactly right. So with the voltage going up and the voltage going down, the LEDs coming on, the LEDs going off. So let's make this happen now and let's do this for us. So what I want to see now, let's go to our examples. We're going to go to our blink, okay? I think we just had us on screen and I was just taking it off. Sorry about that. Okay, but this is our program. This is what we're going to do. So we're going to change this now. All right. So we're going to top it from flashing once a second to 10 times a second. So we're doing 100 milliseconds rather than 1,000 milliseconds. Okay. Okay. All right. So what we're going to do is this program now, we need to tell it where it's got to go to. We've got to tell it what type of chip. So board Arduino, so Arduino Uno, and that's written on here. And this is at COM3, but we're not on COM3, look, we're on COM4. Okay, so now we've done that, this funny little button up here, we can press that, and the program, you can see the LEDs are going to start going bonkers. Okay, there we go. That's it.
And that was entirely down to our changing of the program.
Yeah, absolutely. And it was that quick and that easy. And next time round, so if we change it to from 100 milliseconds to 500 milliseconds, it takes this long to do that. So we delete that and put it onto a 5. And delete that and put that onto a 5. Press that again. Some of these LEDs coming over here showing us that we're transmitting the program. And there we go, we're now on half-second loops.
Fantastic.
Cool.
Okay, so where are we going to go next week then? What's the plan?
So then I think the plan next week is we're going to connect LEDs to here,
yeah.
So separate LEDs and get them up and working, and then we can dim them as well.
Fantastic, yeah.
Happy with that?
Happy with that.
All right, till next week.
Till next week.